to Mars. Yeah, so you've probably figured out our maps of Arizona are to scale with the Mars map. So you can see the Grand Canyon that you guys are going to see is right there. And this is Mars's Grand Canyon. Just put it in perspective. You know, ours is pretty good.
Do you guys bring this LPSC? This is amazing.
No, it weighs so much. It's extremely heavy. What's that? Oh, that's beautiful. That's really nice.
Mr. Dr. Ryan is trying to tell us about Mars. Thank you. You want to be careful with that. That's okay. It sounded.
Yeah, so we picked this area just because of the dramatic topography, the giant canyon and the link with the Grand Canyon here in Flagstaff. And then, you know, likewise the volcanoes, you know, our volcanoes are a little bit smaller here. But the giant shield volcanoes on Mars, they're the same type of volcano as in Hawaii, just much bigger because they've been sitting in the same place for a very long time. Yeah, you can walk on it. It's made of flooring material. You can walk and drive on it if you want. You could be a frog on it too. The first frog on Mars. Wow.
Wonder how big this guy is.
So here's your scale bars.
He's still massive.
It's still a huge crater.
Wow. That's awesome.
Okay, so we'll spend 1 or 2 more minutes in here and then head out.
Gotta pull us along. Sorry. I'm like walking. That's okay.
Hey. Go on through.
There's just so much to look at. I know, look. It's a rolling bird.
You guys get to see this all the time. No, not right now.
Don't mind them. They'll make it. Oh, look at these. Oh, I didn't notice. Oh, no. I like going off the ledge.
Oh, is your one like this?
Yeah, I like how you're
No problem.
taking a break.
Okay, are we gathering?
All right.
All right, I'm going to start walking.
Good idea.
It'll force us to follow.
Yeah, people will eventually catch up.
Is this real newspapers?
Yep.
Wow. 1 second.
Yeah, these are just articles. These are probably pretty out of date at this point, but they feature us.
Yeah, they're retro.
Yeah, that's what makes it sick. No, it's okay, it's okay. Get your picture. I just don't even know what to look at.
Look at this.
Oh, yes. It's a whole hole. I love this.
Oh, that's weird.
Yo.
So some people can walk a little bit past me so that I'm sort of in the middle of the group.
Are those still hollows, right?
Yeah, those are the hollows on Mercury.
I don't want to know because I'm not moving.
This is the aerial Venus.
Okay, well, welcome to our solar system tour hallway. Since you all are geologists learning about planets, I won't go into all the detail that I do with people who have never heard of Mercury and don't know what it is. But I'll talk a little bit about sort of the link to USGS and what we do here. So this first display obviously is Mercury. We're going to work our way out farther from the sun. But we highlighted in the middle here on Mercury this topographic map because our scientists and computer scientists actually worked with messenger data and developed a new way to process all that data together into a giant point cloud to make a topographic map of Mercury. And it was sort of more images than anyone had ever put together before into a topographic map. This was a few years back now, but it required some significant sort of behind-the-scenes data wrangling to get that to work. But we produced this high-resolution map of Mercury. We wish we had more to do with Venus, as all planetary scientists do, but there's not a lot of recent data, so there's not a lot of stuff I can tell you about that we've been involved with on Venus recently. But of course, any future missions that send back images or topography or anything, we'll be involved and we'll help process those and work with them. So let's move down a little bit. Of course, planet Earth is a significant part of what we do here at USGS. Let me let the group catch up here. And you're probably all aware, but USGS partners with NASA to run the Landsat satellites. And so here's just a selection of very artistic-looking Landsat images. But it's just to highlight that Earth is a planet, and we use the same remote sensing techniques we use on other planets to study the Earth. It's just a lot easier to do the Earth, and we get a lot more data. So Landsat, of course, is a huge deal at USGS, and it's a super useful data set. And as we'll talk about later, when you're doing analogs, it's also super useful. So you can look at things like these linear dunes in the Sahara and see the exact same thing on Titan and compare and do studies like that. But we'll keep moving down here a little bit. So this is our stop for Earth's moon. Of course, we already talked about Apollo, but one link between USGS and the Apollo missions that I didn't mention is that the Apollo astronaut Jack Schmitt actually worked here before he worked at NASA. And so he was the only geologist who went to the moon. And this little display here about the orange soil highlights one of his discoveries on the moon. And arguably, probably anyone would have noticed bright orange soil on the moon, but it was nice to have a geologist notice it and take really good samples. And so those samples came back to Earth, and it turns out they're glass that's full of titanium from a volcanic eruption. And so those were really unexpected. No one really expected bright colors on the moon. You kind of picture it as black and white, but there are actually colorful soils up there. And of course, these pictures, these are, if any of you have taken mineralogy, you'll have flashbacks to stuff like this. These are thin sections with cross polarizers, so you get these beautiful colors. And if you've ever looked at thin sections from the Earth, you know that they're all grungy and dirty because they've been altered by water and stuff, whereas the moon looks like a stained glass window. The crystals are beautiful and perfect because they're so dry. And so just makes for a really beautiful display, but also highlights that the moon is different. Even though we recognize all the minerals, they're in a different condition than what we usually see on the Earth. So we'll move down here to Mars. And we are very involved in Mars missions. You're surrounded by Mars, both sides. But we're involved in both orbital and rover missions on Mars. I'm involved in both Curiosity and Perseverance. Others in the building are involved in the HiRISE mission and others. But we also provide the data processing for a lot of that orbital data. In fact, we're just working right now on releasing a huge amount of HiRISE and CTX data, CTX DTMs all over the planet. that have been processed. So it's the stereo topography. And that's just going to be the tip of the iceberg. We're working on, we have a team here that's working with supercomputers to process all of it, like all the data. And so in the next couple of years, there's going to be massive amounts of data that we have processed that people like you can just grab and use without having to line stuff up and tweak things and stretch things. It'll just show up in the right place. And if you've worked with orbital data before, you know that's a big deal. That saves you a lot of work. So that's coming soon. But like I said, we're involved in the rovers. We do operations. We do data processing for the rovers as well. So Mars is, of course, a huge area of interest. We have a lot of people doing research and the more technical side of things. I'll just briefly mention asteroids, comets, small bodies as we sort of pass through the asteroid belt. But we've been involved in the missions there as well. And you know, there's a lot of interest in these small bodies. You know, Sirius turns out has a bunch of water. Who knew? So, of course, as we go back there, we'll be involved. Small bodies are a real challenge for us because, you know, USGS traditionally does mapping and projecting things onto a nice flat surface. What do you do when your body's shaped like a dumbbell? It's hard, and I'm not sure we've solved it yet, but it's a real challenge for the cartography to work with a body that's all lumpy and not even convex. And so we have people who are thinking about that and working on it, partnering with other groups at JPL or APL to try to figure out how do you map something like that and preserve what it should look like. I think the answer is you just work in 3D, but you know, there's something to be said for being able to print out a map sometimes. So we'll continue on a little bit. Similar to Venus, as we get into the outer solar system, the data is not quite as current. We have a lot from Galileo here, the Jupiter's moons, but we have a lot of people who are studying the moons. We have volcanologists in our building especially who study Io and study the activity on the moons. And even though we don't do atmospheres, we were involved in the Juno cam, the camera on Juno. We helped get that camera and work on the data processing for that camera so that it could be projected correctly. And you know, these are these spectacular pictures from Juno. Even though it's not a mission that really uses the images a lot, they're mostly a public outreach tool. We were involved in processing those, and yeah, it's amazing. It boggles my mind every time I remember that they almost didn't send a camera on that mission because because it's spectacular. Likewise with Saturn, the planet itself we don't do a whole lot with, even though it's beautiful and amazing and interesting, just because we have a couple people who do atmospheres, but not a lot. And so most of our involvement is on mapping things and placing pictures in the right place on planetary surfaces, like on the moons. I'm trying to think. Oh yeah, around the corner, I'll show you a picture. You know, Titan's amazing and weird and cool, one of my favorite places in the solar system. And a while back now, but we had some people involved in the Cassini mission, and they helped process the radar swaths that revealed that giant collection of seas and lakes of methane near the North Pole of Titan. And so around the corner we have a printout of that North Polar mosaic that we made. But Titan and Enceladus, both super fascinating. We have people who've been working on Enceladus, making shape models and the topography of the whole planet, the whole tiny moon. But yeah, we're involved in these icy moons as well. We'll get to Uranus and Neptune. We don't have a lot going on just because there's not a lot going on with those lately. But back in the day, one of our emeritus scientists, Larry Soderblom, was very closely involved in the Voyager missions, and he actually helped discover these the streaks from the liquid nitrogen geysers on Triton, among many other things on that mission. So we're looking forward to getting back there and getting better maps of these moons. But what we have is still pretty amazing, very bizarre places. You may have noticed, those of you who already went past, this is our data center. We are a node of the planetary data system. And so pretty much every image taken by a NASA mission is in that room. It's we store and back up those images and provide them to scientists like yourselves to work with.
I'll have to get closer because like all I see is us.
Yeah, try going at an angle. You might.
Oh, okay, look at camera work over here. I know something.
Yeah. So yeah, we have the data system. We also have a compute cluster that we can.
Oh, is this legal for us to be? Okay.
Yeah, I mean, but we use that to process all these images. But we're actually outgrowing that, and some of the stuff that I was just mentioning, we're now using the true supercomputers that USGS has elsewhere in the country. With they do what would take your laptop 30 years, they do it in a few hours. Because we're getting to the point where there's just so much data. It takes forever to work with it. So we're going to try to do that for people and just provide it. Yeah. Last but not least, especially in Flagstaff, Pluto, which is not a planet, but is a really cool place. And I had to print this one big when we were making these displays because it's such a spectacular picture.
Wait, I was over here.
Welcome to Pluto. Yeah, a few years ago when this flyby occurred and we got this picture back, I think everyone's jaws were on the floor because no one knew it would be like this. Everyone kind of expected a dead, dull ball of ice. But look at this. It's got mountains. It's got these flat plains with no craters, which means they're active. They're actually convecting nitrogen slush. It has the complex atmosphere, layer after layer after layer. No one expected that. And then you compare it with its moon, Chiron, in that mosaic there, and Chiron looks pretty dead. It's got some interesting features still, but it's not. It doesn't have these active plains that are completely crater-free the way that Pluto does. So a very interesting system. No one really expected it. In Flagstaff, Pluto is a sore topic because it was discovered here in Pluto. It was discovered here in Flagstaff, and a lot of people want it to be a planet. I'll just give my like 1 minute reason why it's not. It's like, okay, when they were studying the asteroids, and they first found the asteroids, found Ceres. Oh my gosh, it's amazing. It's a new planet. And then they found another one. And then they found another one. And then they found another one. And they're all in the same area. And finally people realized this is not a new planet each time. This is a population of similar objects. And the exact same thing is repeating itself in the outer solar system, where you find a big icy thing. You think, oh great, a planet, this is awesome. But then you find another one. And then you find another one, you realize, this one, its orbit's all tilted and weird, and that one's bigger than this one. And so we're realizing that they're just part of the Kuiper belt. It's sort of like a second asteroid belt. It's much bigger, much farther out. The objects are icy and they get larger than the asteroids, but it's the same process where now that we know more, we can more accurately classify them. Still fascinating places, still worth studying.
Ooh, it's a planet.
Boo. That's fair. So that's sort of the end of the solar system tour. I'll just briefly talk. We have some maps of the Mars rover landing sites, and then we'll go down this hallway with the panoramas. And then I guess we should take a quick look at the analogs display as well before we go see the analogs talk. But these are the maps of the Mars rover landing sites. So this is Gale Crater. This is Gusev Crater for Spirit. This is Meridiani Planum for Opportunity. And we've put the traces of their traverses. These two missions were complete when I made these maps. So this is the full traverse, and you can see how ridiculously long those missions lasted compared to what they were planned for. So Opportunity lasted 14.4 Earth years, 5,111 sols instead of 90. Pretty good. Spirit wasn't quite as lucky as Opportunity. It only lasted 2,209 sols out of 90. Pretty weak, Spirit. But Spirit,
Did you work on Mars?
yeah. Yeah, I was involved with MER in grad school. My advisor was Jim Bell, who was in charge of the color cameras on those rovers. So that was my first taste of Mars rovers. And then Gale Crater, this mission is, of course, still ongoing with Curiosity. But this is a topographic map to highlight the fact that we're climbing up a mountain. We're climbing up the layered rocks in Gale Crater, working our way through them. Since this map was made, we've moved up to somewhere in here. I forget exactly where we are right now. But we're continuing to work up the layered rocks in Gale Crater, still finding all sorts of crazy, weird stuff. And our most recent rover, of course, is Perseverance. And we don't have the Traverse map because I printed this before we landed. So this will be updated one of these days. But this is the delta in Jezero Crater where Perseverance landed. And the sort of key link to USGS is that we actually provided the map that the spacecraft used to land. This spacecraft had new technology on it that allowed it to carry a map on board and watch the ground in real time and match up that map to what it was seeing in real time and avoid obstacles. And so using that map that we produced, it came down and it said, that looks like a bad place to land. We're going to land over here. Sadly, it was on the far side of this obstacle from the delta, so we had to go around, but that's okay. We landed safely, and that's the important thing. And so we were really proud to provide that map for NASA to use, and then in future missions, we hope to continue to do that. So how about we do analogs, and then we walk back through the Mars Panorama hallway, just because panoramas are mostly just pretty pictures. So we'll... Pardon?
Is this Akator?
Yes, this is Akator Crater. And this is the mosaic of the North Pole of Titan that I was talking about. This, I'm not a moon person. This is a giant crater on the moon.
Fair enough.
Copernicus? I don't know.
How far are we going?
We're going just around the corner,
Okay.
and then we'll come back. So right here.
Oh.
So this stuff probably looks a little bit familiar.
Yeah, we'll go.
Wait for people to catch up. This will look familiar. Yeah, so all these pictures are from the eruption a few years ago. We had a few people who went out and helped with the response because it was sort of an all-hands-on-deck situation. But you know, here's some of our people taking temperature measurements and field measurements.
How do you measure?
You stick a probe into it. You stick a thermometer right into it. Yeah, you can see they're not. They're shielding their faces.
Ask Liz to tell you about the Brentford stratosphere.
Oh.
It's good stuff right here. So, how can I purchase one of these? I know.
Well-
I have a spot in my living room.
Yeah, let me think. Most of these are just photographs that our people took.
Oh, not this, like the crater.
But over there, those are online.
No, I want that size.
You want that printout?
No, not that
All right.
printout, but that size.
That size. I'll see what I can do. So obviously, I wanted to bring you guys over here because you've been in the field, you're going to be in the field more, looking at analogs. And so we do a lot with analogs here, and you're going to hear all about it from Amber and Elise. But analogs are the link between our planet and these other planets. You know, you see something weird on another planet, you try to look for it on Earth so you can actually study it up close, and vice versa. Studying things on Earth, that way when you are looking at other planets, you can say, oh, I recognize that. That's a cinder cone. That's a sand dune. And you have a place to start. You know, it doesn't always help you when you go to the South Pole of Mars or you go to Pluto and there's convecting liquid nitrogen. We don't have an analog for that. But we do have analogs for volcanoes and impact craters and sand dunes and many of the things that we see on the terrestrial planets like Mars and the Moon. And even on Titan, there's sand dunes and things. So the analogs provide a really important link, and I'll leave it there and let Amber and Elise tell you more about the analog program, but I just wanted to bring you guys around the corner to see these before we go back to Mars.
Can I ask, so are all these photos, these are examples of analogs that y'all have used
Yes.
in the past? So what is, because that looks like arches at the end, what is that an analog for?
Take a look at pictures from Gale Crater on Mars.
Okay, heard that. I will.
The sandstone of the desert Southwest is very, very, sometimes it's rivers, but sometimes it's not in these craters. Like, where's the river going to go? And, you know, Jezero Crater, the river does go out. Gale Crater, it's more of a, all rivers lead inward. But the general geology is very similar. These sedimentary rocks that have been heavily eroded into complicated buttes and things. We haven't seen any big arches like that, but it's not all that different.
Cool. Thank you.
Yep. All right, so let's do an about face and just walk through the Mars panoramas, and then I'll drop you off for the talks.
Look at that.
Ahoy, hoy.
Sheesh, ahoy, hoy.
Correct.
Good job.
Say it again. This one?
Oh, that falls.
Yeah.
With water.
With water, right? Nobody's ever seen it dry.
Yeah, I just haven't gone.
When I buy a house, the current housing market went for another 25 years. I'm going to plaster every wall.
Yeah.
Maybe I have one room.
So we're just going to go down this hallway to gawk at Mars.
Oh, we can always go.
We can go down in. Everybody's so polite. Walk down the hall.
It's safe. So these are our selfies. We've got Perseverance here, and this is the selfie that includes our little helicopter friend, Ingenuity. This is shortly after we dropped it off. We drove away and let it do its first test flights here. But this is in Jezero Crater, and you can see in the distance, this is the delta. And in this bigger panorama here, you can see a lot more detail. But, and if you have sharp eyes, the helicopter is somewhere in this panorama as well. It's very small. So this is the view from the floor of Jezero Crater in that map. And then this is the view in Gale Crater, partway up the mountain. These are some of those layered rocks I was talking about that have been eroded into these mesas. It's kind of interesting, even though I work on these missions, printing them out this large, it's totally different. You know, I'm used to working on my computer and I see the picture, okay, that's cool, whatever. But when you print it out like this, it's like, oh my God, that's amazing. These hills here, that's the delta. The taller hills are the crater rim. And this is the Kodiak rim.
Yeah.
Yep, so if you have sharp eyes, you can see the four set beds of the delta. Oh, there's the helicopter.
Nice.
There it is.
Little dot.
All right, and we'll just go down and around the corner. We have a Mur panorama coming here, but we ran out of staples. We printed it like 2 weeks ago. So this is Curiosity in Gale Crater, looking back out over the crater floor at the crater rim. This is from a couple years ago now, but you can see the rest of the mountain up here. Yeah, it's so dirty. It's been through some sand dunes, been through some dust storms.
That's what our vans look like right now.
Yeah. It's another analog.
Please don't do the wheel damage to vans that we spent for.
I know, yeah, we don't want that.
Yeah, vans don't drive on wheels that look like this. Show a contrast in the topography between Gale Crater and Meridiani. Meridiani is flatter than a pancake. But this is a really interesting picture. It's in this field of sand ripples, and this was when we're really trying to drive the rover and get to another crater, get past all this sand and get to some crater, get to some bedrock. And we told the rover to drive a long way, and it said, okay. And it drove itself straight into a sand dune and just spun its wheels. And it was stuck there for, I think, a couple months. It almost was stuck there permanently. And so we learned a lot of lessons about what to tell your rover to do. You don't tell it to turn your wheels enough to go X amount of distance. You tell it, take pictures, make sure you're still moving. If you're not, call home. So the newer rovers are smarter about that and avoid obstacles like that. But it's also just a really dramatic picture because it's just so flat and you just see the tracks stretching off into the distance. So I will end the tour there. We're going to wrap around the end and then walk back to about halfway down the solar system tour, and that's where the room is where we'll do the talks.
Thank you so much.
Yeah, no problem.
You guys go ahead, I'm slow.
It'll show all about planetary mapping and map projections and things like that. But those take a lot more effort than just printing out a giant panorama. So they've taken a while, but
Could just put up the maps, right?
we could. And we've talked about that.
That's how I decorated my house.
Fair, that's fair. But one of these days we'll have nice big displays similar to the solar system displays. How did I do on time? Let's see.